We're going to take a look at a very special type of equation. It doesn't show up a lot, but we're going to take a look at equations with rational exponents. Now, not just any type of equation with rational exponents. Unfortunately, we're going to take a look at just a very specific case. We're going to look at equations that can be written in the form of x raised to a fractional power equals a constant. So basically, we only have one term that has the variable with it. It's raised to a fractional exponent, and then everything else is numbers. So one term with the variable raised to a fractional exponent or rational exponent, and everything else is numbers. Okay, the good news is I know it's a very specific type of equation, but if we can recognize something that looks like this, then there's some pretty easy steps to help us solve these. So let's take a look at our steps. Step one, isolate the term with the variable. All right. Now, the whole concept behind there is, let's say, just a very, very quick example. Let's say we have x to the 2/3 equals 5. And I'm trying to get x alone, so I need to get rid of this exponent. Well, I know that if I take any number, let's say our 2/3 there, and I multiply it by the reciprocal, any number times its reciprocal will always be 1. So if I take this expression and I raise both sides to the reciprocal power, since we know for our rules of exponents, we multiply powers when we have a power raised to a power, that's always going to be a number times its reciprocal, which is always going to give us a 1. So there we go. We have our x isolated. So here's what we're going to do. That's the concept of how it should work. So step 2, raise both sides to the reciprocal power. Now, a quick note, if the denominator close enough, that's the word denominator, is even, you need a plus or minus. Hey, so the idea here, so let's take, I'm gonna put this example back I just had a second ago, 2/3 is equal to 5. If I raise both sides to the 3/2 power, here my denominator is even. Now, when you have a fractional exponent, you're actually doing two things at one time. You have a power and a root, which means I just raised both sides to the 3rd power, and at the same time, I took the square root of both sides. So you notice, if the denominator is even, when you take the even root of both sides, you need a plus or minus, so you gotta watch out for that. Okay, once you've done that, you may have to solve a simple little equation after that. So next one, I'm just gonna say solve whatever's left over. Now, 4 isn't much of a step, or may not be much of a step, if the original exponent had an even denominator, you have to check. So just like before, remember a fractional exponent is a power over a root, so technically these are radical problems, and we know if we have an even root radical, we have to check our answers. All right, let's try just a couple of these really quick because they're really not that difficult to solve. Just a couple of things that we have to watch out for with these denominators being even. So again, our directions are just going to be solve. Let's start if I have 2x to the 3/2 minus 5 is equal to 8. Okay, so, sorry, 7, how am I going to do that? Let's make 7, let's do 9. Okay, just making the numbers a little bit easier. Okay, so here we go. Now, how to classify this? A couple of different ways that we could do it. Technically, it is a radical problem because we have a fractional exponent. Or we can put it in terms of today's lecture because all we have is the variable raised to a power and everything else is numbers. So we can isolate this thing being raised to a power. So here we're going to add 5 to both sides. So that gives me what, 14. And then divide both sides by 2. So I have x to the 3/2 is equal to 7. All right, now that I've isolated the thing raised to a power, now I can get rid of that power by raising both sides to the reciprocal power. So I'm going to raise both sides to the 2/3 power. On the left-hand side, power raised to a power, we multiply. And of course, you multiply a number by its reciprocal, the result is 1. So we just get x is equal to 7 to the 2/3. Now, there's not many ways that we can simplify that, so that's probably how we would leave our answer. Now, quick check. Do we have to check this answer? Well, our original problem did have an even denominator, so we have to check. You're like, oh my God, how am I going to check that mess? Well, believe it or not, it won't be as bad as you think. So this is going to be 2 times, our x was 7 to the 2/3 raised to the 3/2 minus 5 should be equal to 9. Again, power raised to a power here we can multiply, so that's just 2 times 7 minus 5 is 9. 14 minus 5 is 9. All right, so this does check, so that is our answer. All right, so let's try another one here. Let's move it over here. I think we might have enough room. What if I have x minus 4, let's just do to the 2/3 power minus 5 is equal to 11. All right, to classify this, again, technically this is a radical problem because we have a fractional exponent. Remember, that's really just a radical, but it does fit the form of this, this lecture with the rational exponents because we just have something raised to a power and everything else is numbers. So our steps say, let's go ahead and isolate this. So if we add 5 to both sides, I get x minus 4 to the 2/3 is equal to 16. Then I'm going to raise both sides to the reciprocal power. So I'm going to take this x minus 4 to the 2/3 and raise it to the 3/2. And I'm going to take this 16 and raise it to the 3/2. Now here's one of the steps you have to really be careful. Because what did we just do to both sides? Again, we cubed both sides, but we also took the square root of both sides, which means we need a plus or minus. All right, so on the left-hand side, power raised to a power, we multiply. We just end up with x minus 4 is equal to plus or minus 16 to the 3/2 power. Now remember, there's 2 things here. Let's scribble this down. I can fit it right here. So let's see, 16 to the 3/2 power, that's really the square root of 16 to the 3rd. The square root of 16 is 4 to the 3rd, which is 64. So remember, when you're applying a fractional exponent, you always try to do the root first, which we can. We know the square root of 16 is 4, then apply the power. If you can't apply the root, then you're kind of stuck, kind of like over here. This is the cubed root of 7 squared. Well, since I don't know what the cubed root of 7 is, there's really not much of a way to simplify that. However, here I knew what the square root of 16 was, so this will simplify. So this side just becomes 64. So to solve that, if we move the 4 over, add 4 to both sides, we have 4 plus or minus 64. Now, since these two are like terms, we can keep going a little bit more. We can write this as 4 plus 64 and 4 minus 64. So we get 2 answers. 4 is equal to 68, and x is equal to, what's that, negative 60. All right, now a quick kind of look, do we have to check these solutions to see if they'll work? Well, from our original problem, our denominator was odd, so we do not have to check these answers. All right, this is a pretty special case of type of problem that you have to solve, but anytime you have just something raised to a power and everything else is numbers, technically this will work. These same steps will work every single time.